Hello everyone, it's me Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 4 Linear Inequations. We'll understand all the concepts clearly and solve questions from exercise 4A. Ready? Yes? Let's start. Before going on to linear inequation, let's first understand what equation and inequation is. What is the main difference between equation and inequation? Equation. Let's take an example. Here we have a boy. He is going to a shop to buy bowls. He gave shopkeeper 50 rupees and he got some bowls. Let's say he got 5 bowls for 50 rupees. Okay. He don't know the cost of one bowl. Let's take the cost of bowl is equal to X. Okay. Now how can I express this? He gave 50 rupees to the shopkeeper and bought 5 bowls. Each bowl cost X rupees, which means 5 into X is equal to 50. I can write like this. Why? Because total cost is 50. That is why shopkeeper took 50 rupees and gave him 5 bowls. From this I can find the value of X because LHS and RHS are equal. When you express an equation, we'll be having an equal to in between. Okay. This sign shows the left hand side and right hand side are equal. Clear? From this I can find the value of X. X will have only a single value. Remember this point. The value of X. Here, what is the value of X? X will be equal to 10 rupees. He is buying 10 rupee bowls. 5 bowls he is buying. That is, the total cost is 50. X will be having a single value. Now let's understand the second case. His friend saw this and he also wanted bowl. Friend went to the shopkeeper. He also gave him 50 rupees because he understood that if we go to shop with 50 rupees, we'll be getting bowls. But here, this friend wanted only 3 bowls. So the shopkeeper gave him 3 bowls. But what happened is that along with its 3 bowls, he gave some amount in return. But he didn't understand why this amount was given. What does this mean? The cost of bowl, the total cost of 3 bowls is not equal to 50. That is why he gave some amount in return. 3 bowls of X rupees. We can write it as 3 into X. The total cost, that is the total amount he had is 50 rupees. That is the amount that he gave to the shopkeeper. What do you understand from this? Is 3x equal to 50? We said 3x is not equal to 50. Yes, 3x is not equal to 50. This is a sign of inequality. Okay. We have 3x less than 50. That is why the shopkeeper gave him some amount in return. This expression 3x less than 50 is an inequation. This is how you can express an inequation. Why? Because here the left hand side is less than right hand side. If the left hand side is greater than right hand side, then also it is an inequation. It is an equation only when there is an equal to between the left hand side and right hand side. Here the value of X. Do you think X can take only one value? No, X can take multiple values. Only condition is that when you multiply X with 3, you should get a number that is less than 50. You can get multiple values for X. Okay, remember this point. X can have multiple values. This is the idea about equation and inequation. We studied in case of an equation, equal to sign is present in between the left hand side and right hand side. When it comes to the case of inequation, the sign is different. Here we have the less than sign between the left hand side and right hand side. Clear? Either the left hand side will be greater or less than the right hand side. This is how we express equations and inequations. Got the basic idea? Now let's see what linear inequations are. Now we know the difference between equation and inequation. In case of equation, there is a sign of equality. In case of inequation, there is no equality. Now what is a linear inequation in one variable? Let's again start with an example. Here we have a boy. His name is A. Okay. We don't know his age. We are going to express his age. Let's say his age is X years. Okay. He has a younger brother who is 3 years old. Let's call him B. His age is 3. Now, how can you compare the age of A and B? Or how can you relate age of A with age of B? The only thing that we know is A is elder than B because B is his younger brother. Yes? Age of A is X and age of B is 3. A is elder than B, which means age of A is greater than age of B. That is, we can express it as X greater than 3. This is an inequation. Here the inequality that I used is greater than. Now, he also has an elder brother who is going to school. Let's say his name is C and he is 9 years old. We know A is younger than C, which means age of A should be less than age of C. That is X less than 9. Here again, I am using an inequality. Which is inequality? Yes, I am using the less than sign. Less than is the inequality I used. So, greater than is an inequality. Less than is an inequality. Now, for example, A is very studious. He writes an examination and teacher said him that you scored A+. But she didn't tell what his exact score is. Okay. To score A+, he knew that at least he should get 45 marks. 45 or above 45. He should get to get A+. That is, it can be 45, 46, 47, 48, 49 or 50. Let's say the mark he scored is some Y. Okay. He should get 45 or above 45, which means his mark should be greater than 45. Not just greater than 45, greater than or equal to 45. If he gets 45 marks, then also he will be getting A+. Clear? To get A+, at least he should get 45, for which we are using another inequality, that is greater than or equal to. This is our third inequality, greater than or equal to. But what happened is that his friend failed in the examination. Teacher said you failed in the examination. Only if a person scores above 10 marks, he will be passing the examination. How can I express this? Failed in the examination, which means he didn't score above 10. Let us take his marks as Z. Z is less than or equal to 10. Above 10, only if he scores above 10, not equal to 10, above 10, he will be passing the examination. Since he failed in the examination, it means his score is less than or equal to 10. This is our fourth inequality, that is less than or equal to. We got the 4 inequalities. Now let's write some expression, like for example, x plus 1 less than 5. Here the inequality that I used is less than. This is an inequation. Then x by 3 greater than 4. Inequality used is greater than. This is an inequation. Then x minus 3 greater than or equal to 10. This is again an inequation. I am using greater than or equal to. X by 5 plus 4 less than or equal to 20. This is also an inequation. The inequality that I used is less than or equal to. Clear? Now what does this linear mean? We have linear inequation. In all this expression, the power of x is 1. Okay, it's not x square or x cube or x raised to 4. It is 1. That is, the degree of x is 1. degree of x is 1. This is why we call all these inequations as linear inequations in one variable. Here we are just using a single variable, that is x. Okay, the only variable used is x. Clear? Linear inequations in one variable. Linear means the degree is 1. Inequations means inequalities are used, that is less than, greater than, less than or equal to, greater than or equal to. In one variable, we are using only a single variable, that is x. General form of linear inequation. We all know the general form of linear equation. We have studied linear equations in one variable, linear equations in two variables, with x, with y, etc. Ax plus b is equal to c. This is the general form of linear equations, where a, b and c are real numbers. A, B, C are real numbers. And one more condition, a not equal to 0. Ax plus b is equal to c is a linear equation where a, b, c are real numbers and a not equal to 0. Why do we say a not equal to 0? What happens if a is equal to 0? When a is equal to 0, ax will be equal to 0. 0 into x is 0. Then can we call this an equation? We need a variable and a constant. At least a variable and a constant should be there for it to be a linear equation. Once a is equal to 0, a into x will become equal to 0. In that case, we cannot call this an equation. Both left hand side and right hand side you have to take into consideration. Clear? For example, if a is equal to 1, b is equal to 2, c is equal to 3. Here I have used real numbers. Okay. Then the equation becomes 1x plus 2 is equal to 3. This is a linear equation. Now, how to write a linear inequation? The general form of linear inequation. This is very easy. Just replacing this equal to sign with any of the inequalities. Let's take the first one. Ax plus b less than c. Here I have used the inequality less than. Second, ax plus b greater than c. Using the inequality greater than. Ax plus b less than or equal to c. Here the inequality used is less than or equal to. Ax plus b greater than or equal to c. This is the general form of linear inequation. We are just replacing this equal to sign with the inequalities. We have studied the 4 inequalities: less than, greater than, less than or equal to, greater than or equal to. Again, we should include this condition. That is, a, b, c are real numbers. A, B, C are real numbers and a not equal to 0. This is a general form of linear inequations. Let's put some values for a, b and c. The first equation we can write it as 1x plus 2 less than 3. This is a linear inequation where we have used the inequality less than. Second, 1x plus 2 greater than 3. Using the inequality greater than. 1x plus 2 less than or equal to 3. Here the inequality is less than or equal to. 1x plus 2 greater than or equal to 3. When greater than or equal to is used. Got the idea? This is how the general form of linear inequation is. If you know the general form of linear equation and the conditions, just need to replace this equal to with the different inequalities. You will get the general form of linear inequations. Clear? By now we know what linear inequations are. We know the 4 inequalities: less than, greater than, less than or equal to, greater than or equal to. To solve this linear inequation, you have to follow certain rules. Let's see what the rules are. We have 6 different rules. First one, on transferring a positive term from one side of an inequation to its other side, the sign of term becomes negative. When we take an example, you can understand it easily. We have 5x plus 4 greater than 10. Here, we are going to shift a term to the opposite side. This is a positive term, plus 4. When I am shifting this plus 4 to the opposite side, this plus 4 becomes minus 4. The same thing we used to do in linear equations also. Linear equations in one variable or linear equations in two variable, we use the same concepts. When you take it from one side to the other side, you will have to change the sign. This plus 4 should become minus 4. That is 5x greater than 10 minus 4 is your inequation. First rule is clear. Now the second one. On transferring a negative term from one side of an inequation to its other side, the sign of term becomes positive. Here, this opposite thing we are going to do. We have 5x minus 4 greater than 10. When I take this minus 4, this is a negative term. To the opposite side, it becomes positive. Very simple. 5x greater than 10 plus 4. The sign, third rule is, if each term of an inequation be multiplied or divided by the same positive number, the sign of inequality remains the same. This is our third rule. Okay. We'll take this example. 5x minus 4 greater than 10. Now, if I am dividing with any positive number or I am multiplying with any positive number, the sign of inequality should remain the same. For example, let's divide by 2. Okay, I am dividing by 2. Then this sign, greater than sign, remains the same. This is our third rule. Clear? In the first three rules, remember, the sign of inequality does not change. First rule, positive number taken to the opposite side, it becomes negative. Second rule, negative number taken to the opposite side, it becomes positive. Third rule, multiplying or dividing with a positive number does not bring any change in the inequality. Let's move on to the next rules. Okay, we studied three important rules that is used in solving linear inequations algebraically. There, we found that the sign of inequality remains the same. Now, here is our fourth rule. If each term of an inequation be multiplied or divided by the same negative number, the sign of inequality reverses. Here we are dividing or multiplying with a negative number. In our previous rule, we did it with a positive number. Then the sign of inequality remained the same. Let's take an example. 2x minus 2 less than 11. Okay. I need to multiply with a negative number. Let's take minus 2. Minus 2 into 2x minus 2 and minus 2 into 11. Okay. Given that the sign of inequality reverses, which means here we have less than. Less than becomes greater than. Minus 2 into 2x is minus 4x. Minus 4x minus 2 into minus 2, that is plus 4. Greater than minus 22. According to the given rule, we will be getting this. Now putting a value for x, we can confirm if it is correct. Let us take x is equal to 1. When x is equal to 1, you will be getting 2 into 1, 2 minus 2, that is 0. 0 less than 11 is true. Okay. Now here what is done? We have multiplied both sides with a negative number, with the same negative number. And we have reversed the sign of inequality. To this condition, let's put the value of x as 1. Minus 4 into 1 is minus 4. Minus 4 plus 4 is 0. We'll be getting 0 greater than minus 22. This is correct. Hence, we have proved that this rule is true. Clear? Rule number 5. If sign of each term on both sides of an inequation is changed, the sign of inequality gets reversed. Here again the sign of inequality gets reversed. Let's take another example. X greater than y or x greater than minus y. If I take x greater than minus y, in the given rule it is said that I need to change the sign of terms on both sides. X becomes minus x and y minus y becomes y. The sign of inequality gets reversed. Here we have greater than changes to less than. Okay, let's see if this rule is obeyed. X should be a number that is greater than minus y. Let us take y is equal to 1 and x is equal to 5. When I put y is equal to 1, minus y will be equal to minus 1. Minus 1. X is 5. 5 is greater than minus 1. Yes, 5 is a number that is greater than minus 1. Now, for this, I am going to change the signs. That is, plus 5 will become minus 5 and minus 1 will become plus 1. Which is greater, minus 5 or plus 5? We have changed the signs on both sides. You know that is 1 is the greater number. It is following the rule. Value of y is 1, value of x is 5. Minus 5 is less than 1. This is our fifth rule. Here again, the sign of inequality reverses. Now the last rule, sixth one, if both the sides of an inequation are positive or both are negative, then on taking their reciprocals, the sign of inequality reverses. You have to remember this condition. Both sides, either they should be positive or negative. In that case, if you take the reciprocal, then the inequality will reverse. Again, let's take an example. 2 and 3. 2, 3. Which number is greater? 3 is greater. We all know this. 2 is less than 3. Okay. Now we need to take the reciprocal of this. Both of these numbers are positive. When I take the reciprocal of 2, I get 1 by 2. What is the reciprocal of 3? 1 by 3. Now which is greater? 1 by 2 or 1 by 3? According to this rule, we have to reverse this inequality. But I want your answer. Which is greater? 1 by 2 or 1 by 3? If I divide the circle into 1 by 2 part, that is half part, or I divide the circle into 1 by 3 part, which part will be greater? This side or this side? This is 1 by 3, this is 1 by 2. We are sure that 1 by 2 is greater. So our sign will become like this. Hence, this statement is also proved. That is, if both the sides of an inequation are positive or both are negative, then on taking the reciprocal, the sign of inequality reverses. That is, x greater than y implies 1 by x less than 1 by y. Clear? X greater than y implies 1 by x less than 1 by y. We are changing the sign. Greater than becomes less than when you are taking reciprocal. We have all the rules with us now. Yes? Okay. We'll apply this in solving questions. Replacement set and solution set. To understand this idea, let us take a simple example. I have 4 baskets with me. In the first basket, I am filling natural numbers. In the second, whole numbers. Third, integers. And in the fourth, real numbers. Okay, what are natural numbers? Numbers that start from 1, it extends to infinity. They are positive numbers. 1, 2, 3, 4, etc. are natural numbers. When this natural number and 0 is included to this natural number, it becomes whole number. Whole number is a set of natural numbers and 0. When it comes to the integers, in case of integers, we'll be having positive numbers, negative numbers and 0. That is, the basket is bigger. What about real numbers? Bigger basket is required, right? Because here we have to include all of these, that is natural numbers, whole numbers, integers, plus the decimal fractions, etc. So we have a bigger basket to include the real numbers. Now I am given x. X is some variable. And my condition is that I should choose x from the first basket. What are my options? In the first basket, it is given that all the members are natural numbers, which means my x will be a natural number if I choose from the first set. X will be a natural number, that is, x belongs to natural numbers. Now in the second set, if I am choosing x, what will be the condition? It can even be 0. Natural numbers are 0, which means we can write this as x belongs to w, that is, x is a whole number. Next, if I am choosing x from the third basket, that is the set of integers, then x can be negative, x can be positive or x can be 0. That is, we can write this as x belongs to z. Now if I am choosing x from the fourth basket, I have many options. It can be a decimal, it can be a fraction, or it can be some integer, whole numbers, natural numbers, whatever it is. I have many more options there. Then x belongs to R. X is a number that is chosen from real numbers. This representation, that is from where I am choosing x, the set from where I am choosing x, whether it is natural number, whole number, integer or real number, is what the replacement set idea is, from where the variable x is chosen. Clear? Now I am implementing another condition. Let's say x is a number less than 4. This is my second condition. Here already I have a condition, x is a number that belongs to natural numbers. I should choose x only from the basket of natural numbers. And now I am putting a second condition, that is, x is a number that is less than 4. Options are very limited, right? What are the numbers that is less than 4 and is also a natural number? Yes, 1, 2 and 3. We represent this in flower brackets. So this is the solution set. Okay, this is the idea of solution set. That is, we are putting a condition to this. We are representing it as an inequation, and in the inequation condition is given to the replacement set. This is the idea of solution set. Now the same condition I am applying to the basket of whole numbers. X should be a whole number and x should be less than 4. What are my options then? Yes, I can include a 0 to this. 0, 1, 2, 3. Okay. Let's now take the same condition to the third basket. That is the set of integers. Here, x less than 4. We have many numbers, right? Because x should be less than 4. All the negative numbers are less than 4. But I am applying another condition here. I will be saying that x should be greater than -2 and less than 4. Options gets limited. If it was just x less than 4, then I had a plenty of options. I can choose any negative number, 0 or the numbers 1, 2, 3. But here I am giving another condition. That is, I am including two inequalities. That is, less than and greater than. X is a number that is greater than -2. X is a number that is less than 4. In that case, what is our solution set? We will be getting a number that is less than 4. You will have 1, 2, 3, 0 and minus 1. Can we include minus 2? If it was less than or equal to, you could have included minus 2. But here it is less than. Okay. X should be greater than minus 2. Which means our set includes minus 1, 0, 1, 2, 3. Applying the same condition to the fourth set. That is the set of real numbers. What do you get here? When you take just two numbers, let it be 1 and 2. X is a number that is lying between minus 2 and 4. If you take 1 and 2, between 1 and 2 you have a plenty of numbers. You have 1.1, 1.2, 1.3, etc. When you take this 1.1 and 1.2, again you have a plenty of numbers between them. 1.11, 1.12, etc. So representing in this brackets is very difficult, right? In that condition, you represent in another way. You can just put the two conditions that they are following. That is, X should be a number that belongs to real number. X such that X belongs to real numbers. And the second condition that we have implemented. That is, minus 2 less than X less than 4. This is how you represent in case of real numbers, because including every real numbers within a flower bracket is very difficult. So we will just write the two conditions there. Clear? This is the idea of replacement set and solution set. Replacement set is the set from which the value of the variable X is to be chosen. Here we had the 4 baskets. Basket containing natural number, basket containing whole numbers, basket containing integers, and the basket containing real numbers. These are our replacement sets. And what is solution set? The set of all solutions of an inequation. Here, in the first case, we have this set containing 1, 2 and 3. In the second case, it is the set containing 0, 1, 2, 3. In the third case, minus 1, 0, 1, 2, 3. Fourth case, we have given a condition like this. This is the set. Now, this set is a subset of the first replacement set. Yes, what is subset? Subset means a small part of it. Like 1, 2, 3 is a natural number and it is following this condition. So, solution set is a set of all solutions of an inequation and solution set is a subset of replacement set. Remember these points. Clear? Now, let's move on to different examples. By solving example, everything will be clear for you. Now, we have all the concepts of linear inequations with us. Let's together solve the simple example. If the replacement set is a set of natural numbers, find the solution set of. Okay, replacement set is given is a set of natural numbers. First question is 3x plus 4 less than 16. Second, 8 minus x less than or equal to 4x minus 2. Okay, let's take the first one. In the case of first equation, that is 3x plus 4 less than 16. Which is the inequality here? Less than. This is the inequality. Okay. Now, how do you solve this? First rule. We can use the first rule. That is, when you shift a positive number from one side to the opposite side, there is a shift in sign. Here we have plus 4. Plus 4 becomes minus 4 when it is taken to the right hand side. We will get 3x less than 16 minus 4. Does the inequality change? In the rule 1, there is no change in inequality. Okay. Next step, 3x less than, what is 16 minus 4? 16 minus 4 is 12. We have 3x less than 12. To get x in the left hand side, we need to divide with 3 on both sides. Dividing by 3. 3 is a positive number. According to rule 3, when you multiply or divide with a positive number, there is no change in the sign of inequality. Therefore, 3x by 3 less than 12 divided by 3. 3x by 3 becomes x less than, what is 12 by 3? 4. We got the condition. We got the inequation here, that is x is less than 4. Now we have the replacement set. What is the replacement set? Replacement set is given that it is a set of natural numbers. Set of natural numbers. So we need to select the values of x from natural numbers. We know natural numbers starts from 1. 1, 2, 3, 4 and extends to infinity. Here we have x is a number that is less than 4. Less than 4, not less than or equal to. Remember this thing. It is given x is a number less than 4. Also x is a natural number. Natural number starts from 1. Then you have 2. Then you have 3. Can you add 4 in the set? No, right? Why do you add only 1, 2, 3? Because we need numbers that is less than 4. 1, 2, 3 are less than 4 and they are natural numbers. So this is our solution set. Okay? This is our solution set. You will be representing the solution set in flower brackets. Okay? Clear? Now let's take the second part. Second question. We have 8 minus x less than or equal to 4x minus 2. Clear? What do you have to do next? We have to take x containing terms, that is the variable terms to one side and the constant terms to the opposite side. Here we have minus x, bringing 4x from right hand side to left hand side. 4x is positive. It becomes negative. That is minus 4x less than or equal to. We have minus 2 here. Then taking this 8 plus 8 to the opposite side, it becomes minus 8. Minus 8. Minus x minus 4x. Minus x minus 4x is minus 5x. Minus 5x less than or equal to minus 10. Minus 2 minus 8 is minus 10. Next, what can be done? Here we have to remove this negative 5. For that, I can divide on both sides with minus 5. Minus 5 is a negative number. When you divide or multiply with the negative number, what happens? The sign of inequality changes or the inequality reverses. Here we have less than or equal to. It becomes greater than or equal to. This is the rule 4 that we studied. Remember? Yes. Dividing minus 5x divided by minus 5 less than or equal to should become greater than or equal to. Greater than or equal to minus 10 divided by minus 5. Okay. Now we can cancel this. We have x greater than or equal to minus 10 by minus 5 is plus 2. Both the negative signs get cancelled. 10 by 5 is 2. Now this is our condition for x. We know x is a natural number. Replacement set. We have x is a natural number. Now the solution set, we have to write the solution set. It should be a natural number and a number that is equal to or greater than 2. Here we have natural number that starts from 1. Can we include 1 in the set? No, 1 is a number that is less than 2. X should be a number that is greater than or equal to 2. Therefore, we can add 2 in this. Greater than 2 means all other natural numbers are greater than 2. We have 3, we have 4, 5, 6, etc. up to infinity. This is how you represent the solution set in this case. Clear? Both parts. Example 2. If the replacement set is a set of integers between -6 and 8, find the solution set of first part 6x minus 1 greater than or equal to 9 plus x. Second, 15 minus 3x greater than x minus 3. Let's start with the first part. Here the replacement set is a set of integers between -6 and 8. First part it is 6x minus 1 greater than or equal to 9n plus x. We'll take all the variables on one side and constants on the opposite side. 6x plus x. When you bring this plus x to the opposite side, it becomes minus x. 6x minus x greater than or equal to minus 1. When it comes to this side, it becomes plus 1. 9n plus 1. Clear? The sign, that is the inequality, does not change. 6x minus x is 5x. 5x greater than or equal to 10. Yes, 9 plus 1 is 10. Now, we need to divide by 5 on both sides. 5 is a positive number, therefore the inequality remains the same. 5x by 5 is greater than or equal to 10 by 5. 5x by 5 is x, greater than or equal to 10 by 5 is 2. 2. So here we got x is greater than or equal to 2. X can be 2 or a number above that. We have another condition which is given in the replacement set. Replacement set, it is given that the number should be an integer. Also, it should be between -6 and +8. Then what is the solution set? Solution set is equal to, solution set we represent in a flower bracket. The number should be greater than 2 or equal to 2. It should be an integer and it should lie between -6 and 8. So, negative numbers won't come. Even 0 and 1 also should be excluded from the positive part. We'll be having 2, 3, 4, 5, 6 and 7. Can we include 8? No, right? Because the number lies between -6 and 8. In that case, you have to exclude -6 and 8. So, this is the solution set in the first part. Similarly, we'll find for the second part. Second part, the question is 15 minus 3x greater than, here the inequality is greater than, x minus 3. Okay. Taking all the variables on one side, we have minus 3x here. When x is taken to the opposite side, it becomes minus x. Minus x greater than minus 3. What about this 15? It is positive. So, it becomes negative. Negative 15. Minus 3x minus x is minus 4x greater than minus 3 minus 15. You will be getting minus 18. Minus 18. Okay. Now, on both sides, I am dividing by minus 4. Divide by minus 4. Minus 4 is a negative number. We have a rule. While we divide with the negative number, the sign, the inequality reverses. Minus 4x divided by minus 4 greater than becomes less than. Less than minus 18 divided by minus 4. Minus 4 and minus 4 get cancelled. You will be getting x less than minus 18 and minus 4. you will be getting 4.5. 4.5. That is, x should be less than 4.5 is the condition. This is not an integer. Now, the replacement set is the same. That is, an integer that lies between -6 and 8. What is the solution set then? Solution set is equal to, from where should we start? The only condition is that x should be less than 4.5. So, we can include all the negative numbers. Yes, negative numbers from -6 we can include in that. Excluding -6 because it is given that between -6 and 8. We have -5, -4, -3, -2, -1, 0. Now the positive numbers such that it should be less than 4.5. You will have 1, 2, 3 and 4. 4. Okay, this is the solution set in the second case. Clear? Very simple, right? Yes. Example 3. In the inequation 2 plus 3x minus 1 divided by 5 less than or equal to 2x minus 1 by 4 plus 3, write the greatest value of x when x is a natural number, second x is a real number. Here they are not asking you to find the solution set. You just need to find the greatest value of x. First condition is x is a natural number and the second part the condition is x is a real number. We have the inequation 2 plus 3x minus 1 divided by 5 less than or equal to 2x minus 1 by 4 plus 3. This is our inequation. Now let's take the x containing terms. Here on the left hand side we have this term and this is a term on the right hand side containing x. Both the terms that is containing x will be taken to the LHS. That is 3x minus 1 divided by 5, and when you shift this 2x minus 1 by 4 to the left hand side, you have to put a negative sign. Minus 2x minus 1 divided by 4 less than or equal to 3. When you shift this 2 to the right hand side, plus 2 becomes minus 2. Okay, 3 minus 2. In the next step, we can take the LCM. We have 5 and 4. LCM of 5 and 4 is 20. You all know to solve this. Like you solve the linear equation in one variable, similar steps are used here. Just we have to consider the inequality. 20. Then you will multiply this 4 and 3x minus 1. 4 into 3x minus 1. Minus, here we have 5. 5 into 2x minus 1. Next step is removing the brackets. 4 into 3x minus 1 becomes 12x minus 4. Minus 5 into 2x is 10x. Minus 5 into minus 1 is plus 5 divided by 20 less than or equal to 3 minus 2 is 1. Okay, less than or equal to 1. Next step, we have 12x and minus 10x. 12x minus 10x becomes 2x. Minus 4 and plus 5. Minus 4 plus 5. You will be getting plus 1 divided by 20 less than or equal to 1. Okay. Now we have a 20 in the denominator. We can remove this. That is multiplying on both sides with 20. It becomes 20 into 2x plus 1 divided by 20. Inequality is same. That is less than or equal to 1 into 20. Clear? You can cancel out these 20s. You have 2x plus 1 less than or equal to 20 into 1 is 20. That is 2x less than or equal to 20 minus 1. 2x less than or equal to, what is 20 minus 1? 19. Then x is less than or equal to 19 by 2. This is a fraction. Now we can convert it into decimal form. Then x is less than or equal to 9.5. This is our condition for x. X should be a number that is less than or equal to 9.5. Okay, we need to find the greatest value in the first case when x is a natural number. We know what are natural numbers. Yes, 0, 1, 2, 3, etc. up to infinity. We need the greatest natural number that is less than or equal to 9.5. 9.5 we know is not a natural number. Okay, the number that is less than 9.5 and greatest value should be given to x. Which is the number? Yes, x is equal to 9. Okay, x is equal to 9. This is the first case. X is a natural number. X is less than or equal to 9.5. X cannot be 9.5 because 9.5 is not a natural number. The natural number that is less than 9.5 is 9. Clear? Second part. X is a real number. We have the condition x is less than or equal to 9.5. Equal to. X can be equal to 9.5. Next is x is a real number. Is 9.5 a real number? Yes. 9.5 is a decimal and it is a real number. Therefore, the value of x is equal to 9.5. First answer is x is equal to 9 and the second answer is x is equal to 9.5. Clear? Yes? Let's go to the next example. Okay. Example 4. Solve the following inequation. 2y minus 3 less than y plus 1 less than or equal to 4y plus 7. First condition is y belongs to integers and the second y belongs to real numbers. Here we have two inequalities. Less than and less than or equal to. So we have to consider as two different parts. First part including the less than inequality, that is 2y minus 3 less than y plus 1. From that you will be getting a condition for y. Again the second part is this one, that is y plus 1 less than or equal to 4y plus 7. There also you will be getting an inequation for y. Clear? So here we have 2y minus 3 less than y plus 1. That is the first part. How do you solve this? Yes, the first step is taking the variables on one side, constants on the other side. That is 2y minus y plus y becomes minus y less than 1 plus 3. Minus 3 becomes plus 3. What is 2y minus y? Y. Less than 1 plus 3 is 4. Okay. So, the first condition is y is a number less than 4. Now, the second part, that is y plus 1 less than or equal to 4y plus 7. Same steps, taking variables on one side. Here, on the left hand side, we have a y. We'll take this 4y to the left hand side. It becomes minus 4y. Less than or equal to 7 plus 1 to the right hand side. It becomes minus 1. Y minus 4y is minus 3y less than or equal to 7 minus 1, 6. Okay. Now, if I am dividing with a negative number, we had a rule. We have to follow that rule. When you multiply or divide with a negative number, the inequality reverses. Here we have less than or equal to. So, if I am dividing with a negative number, it becomes greater than or equal to. dividing by, to get y, I should divide with minus 3. Dividing by minus 3 on both sides. Minus 3y divided by minus 3 less than or equal to becomes greater than or equal to 6 divided by minus 3. Okay? What is minus 3y by minus 3? You will be getting y. Greater than or equal to 6 by minus 3. 6 by 3 we know it is 2. We have a negative sign. Negative sign is taken to the numerator. You get minus 2. This is our second condition. From this we understood that y is a number that is greater than or equal to minus 2. That is minus 2 less than or equal to y. Yes? And also y is the number that is less than 4. Y is less than 4. This is our final inequality equation for y. Clear? Now, our first question is y belongs to integers. Y is an integer. Okay? Minus 2 is an integer and y can be equal to integer. So, the solution set is, for the first case, solution set is equal to, we represent solution set in flower brackets. We can include minus 2 because here there is an equal sign. Minus 2, then minus 1, 0, 1, 2, till where? Till 4. Can we include 4? No, because here there is no equality. That is the number or the integer just before 4. Up to that we have include. That is 3. This is the answer for first question. There the solution set is minus 2, minus 1, 0, 1, 2, 3. Now the second. Y belongs to real numbers. Real numbers we know includes decimals, fractions, everything. Can we write all the decimals and fractions here? No, right? So we'll write the condition as y such that y belongs to real numbers and the condition we found out. That is minus 2 less than or equal to y less than 4. This is how we represent the solution set when it is given like this. That is y belongs to real numbers. Because we cannot include all the decimals, all the fractions and write a solution set as we did for the first case. Okay? So this is the condition, that is y such that y belongs to real numbers and minus 2 less than or equal to y less than 4. Okay? Yes, let's now move on to questions from exercise 4a. Here is the first question. State true or false. 4 inequations are given. In each of this inequation, we have to find if the given implications are true or false. Let's take the first one. X less than minus y implies minus x greater than y. We can use any of our rules. We have 6 rules. In this case, let's use the 5th rule. That is, when you change the sign of terms, you have to change the inequality. That is, if you are reversing x, it becomes minus x. Then the inequality also reverses. X becomes minus x. What about minus y? Minus y becomes plus y. That is, you have to change the sign in both the terms. That is, on the left hand side and the right hand side. Sign here, the inequality is less than. Less than becomes greater than. This is what from the first inequation we get. Okay. Minus x greater than y. Here we got the same. Right. In the question, what is given? We got the same implication when we used rule 5. So this statement is true. Clear? Now let's take the second one. Minus 5x greater than or equal to 15 implies x greater than or equal to minus 3. Okay. To solve this, I just need x on the left hand side. What should be done? I have to divide with minus 5. That is, we have minus 5x greater than or equal to 15. Divide by minus 5. Minus 5 is a negative number. According to rule 4, when you multiply or divide with a negative number, the inequality reverses. That is, minus 5x by minus 5, 15 by minus 5. What about the inequality? Here it is greater than or equal to. Greater than or equal to becomes less than or equal to. Here we have x. Minus 5 and minus 5 can be cancelled. What about 15 by minus 5? You will be getting minus 3. Less than or equal to minus 3. Okay. This is what is the implication from the first part. But do we get it here? In the question it is given x is greater than or equal to minus 3. Minus 5x greater than or equal to 15 implies x greater than or equal to minus 3. But this is not matching. We should get x less than or equal to minus 3. Which means the statement is false. Okay. This is false. Now the third one. 2x less than or equal to minus 7 implies 2x by minus 4 greater than or equal to minus 7 by minus 4. From the question it is clear, right? Here dividing by minus 4 is what? Done. So we have 2x less than or equal to minus 7. We will divide on both sides with minus 4. Dividing with minus 4, use rule 4. Dividing or multiplying with a negative number, the inequality reverses. That is 2x by minus 4, here minus 7 by minus 4. Less than or equal to becomes greater than or equal to. This is what we get here in the question. This is our implication. Which means this is again true. True. Now the fourth part. 7 greater than 5. Here we don't have any variables. This is something that we know. 7 greater than 5. Implies 1 by 7 less than 1 by 5. This is our sixth rule, in which when you take the reciprocal on both sides, you will have to reverse the inequality. Reciprocal of 7 is 1 by 7. Reciprocal of 5 is 1 by 5. Here we have greater than becomes less than. Okay. Same thing, right? Yes. So this is the implication that we get, and in the question, the given implication is true. Only in the second question, we got false. All other answers are true. Clear? Got the concepts? Next question, problem 2. Question number 2 of exercise 4A. State whether the following statements are true or false. Again, we have true or false. First one, A less than B, then A minus C less than B minus C. What is done here? We are subtracting C from both sides. A less than B, subtracting equal number from both sides. That is A minus C less than B minus C. It is true, no? Which rule? Second rule. Subtracting the same number on both sides does not change the sign of inequality. If you take some random example, you can understand it easily. Let's take the value of A is equal to 1 value of B is equal to 2 and let C is equal to 3. We can put some values, okay? It should obey the condition that A is a number less than B. A is less than B. Here I have taken A is equal to 1 and B is equal to 2. 1 less than 2. 1 minus, what is my C? C is 3. 1 minus 3 and 2 minus 3. What is 1 minus 3? What is 1 minus 3? Minus 2. Minus 2 less than 2 minus 3. 2 minus 3 is minus 1. Minus 2 is less than minus 1. Yes, okay. So, we can say that the given statement is true. Very simple. If you are unable to solve this or if you don't remember the rules, you can just put some random numbers obeying the conditions. Okay. Now the next second one. Given A greater than B, then A plus B greater than B plus C. What do you say? Here what is done? We are adding a number, that is C is added on both sides. Then according to first rule, if you add same number on both sides, the inequality remains the same. Therefore, A greater than B means A plus C is greater than B plus C. Even you can do this with some random examples. Yes? Like I'll take this 2 greater than 1. A is equal to 2 and B is equal to 1. Adding some C. Let C is equal to 3. Adding 3 on both sides. 2 plus 3 is 5. 1 plus 3 is 4. 5 is greater than 4. Yes, 5 is greater than 4. Which means the second statement is also true. Now the third one. If A less than B, then AC greater than BC. Here we are multiplying C on both sides. When you multiply C, what happens? Which rule we are using here? Third rule. Multiplying or dividing with a positive number will not bring any change in the inequality. Which means this is not true. Right? When you multiply this, A into C should be less than B into C. But here it is given AC is greater than BC. This is false. Let's take the example. A less than B. We can take the first example. A equal to 1, B equal to 2, C is equal to 3. 1 less than 2. Multiplying with C. Here the C is 3. Multiplying with 3. 1 into 3. 2 into 3. 1 into 3 is 3. 2 into 3, you get 6. 3 is less than 6. But according to this condition, we will be getting AC. AC is equal to 3. BC is equal to 6. 3 greater than 6. Hence, this statement is false. It is not obeying the given statement. According to the statement, you have to get AC greater than BC. But we are getting AC less than BC. Now, the fourth part. Now, the fourth question. If A greater than B, then A by C less than B by C. A greater than B. Dividing with C. Okay? Dividing with C on both sides. Does the inequality change? Rule 3. Multiplying or dividing with the same number on both sides does not bring any change in the inequality. Therefore, the inequality should be greater than. Here we have less than, which means the fourth statement is also false. Okay. Now, the fifth one. If A minus C greater than B minus D, then A plus D greater than B plus C. How to solve this? just by shifting the terms. I can take this minus d here and minus c here. Minus d, when it comes to the left hand side, it becomes plus d. Minus c, when it comes to the right hand side, it becomes plus c. That is a plus d greater than b plus c. A plus d greater than b plus c. We also solved and we got a plus d greater than b plus c, which means this is true. Now, the last one, sixth one. If a less than b and c greater than 0, then a minus c greater than b minus c. A minus c greater than b minus c. Subtracting c from both sides. A minus c, b minus c. Okay. C is a number that is greater than 0. What do you think here? Subtracting c, which means we are using the second rule. Subtracting same number on both sides will not bring any change in the inequality. Here we have less than. So this also should be less than. But here in the question it is given a minus c greater than b minus c. Okay. True or false? False. Correct. False. That's it. Let's do the next problem. Problem 3. Question number 6 of exercise 4a. If 25 minus 4x less than or equal to 16, find the smallest value of x when x is a real number. Second, the smallest value of x when x is an integer. Question is clear, right? We have done similar examples. Here the inequality is 25 minus 4x less than or equal to 16. Okay? We need to take the variables on one side, constants on the other side. Here the variable is containing term is minus 4x. Shifting this 25 to the opposite side, 25 becomes minus 25. 16 minus 25. Minus 4x less than or equal to 16 minus 25 is minus 9. Okay. Now we have to remove this negative sign. For that we will be dividing by minus 4. When you divide by minus 4, you have to remember, you have to reverse the inequality. Rule number 4. All of you remember, right? Yes. Dividing by minus 4. Minus 4x by minus 4 greater than or equal to. Less than or equal to becomes greater than or equal to minus 9 divided by minus 4. Minus 4x by minus 4. Cancelling minus 4. You have x. Greater than or equal to minus 9 by minus 4. The negative sign gets cancelled. 9 by 4 is a fraction. When you convert it into decimal, you will be getting 2.25. This is the condition for x. X is a number that is greater than or equal to 2.25. Now let's see the first part. The smallest value of x when x is a real number. 2.25 is a real number and we have x greater than or equal to 2.25. That is, the value of x can be equal to 2.25. This is the smallest value of x. We know that x is greater than or equal to 2.25. Either x should be 2.25 or a number that is bigger than 2.25. We need the smallest number. So, the smallest number is 2.25. Smallest real number is 2.25. Okay. The second part. The smallest value of x when x is an integer. Now, it comes to the case of integers. 2.25 is not an integer. Is it an integer? No. Then which is the closest integer? 2.25 lies between 2 and 3. Okay. Now the condition is x should be greater than or equal to 2.25. 2 and 3. 2.25 lies somewhere here. Okay. Which means 2 is less than 2.25 and 3 is greater than 2.25. Here x should be greater than 2.25. X should be an integer that is greater than 2.25. So the nearest value that is possible is 3 and 3 is the smallest value. Yes. So the second question, x is equal to 3. Clear? X is greater than or equal to 2.25. We cannot take 2.25 because 2.25 is not an integer. And the condition is x should be the next greatest number. Because we need the smallest value of x. Yes, the smallest value of x is equal to 3. Okay. Let's move on to the next question. Problem number 4. Question number 7 of exercise 4A. If the replacement set is a set of real numbers, solve first question. Minus 4x greater than or equal to minus 16. Let's start. The first one. Minus 4x greater than or equal to minus 16. Now we are experts in solving, right? We have to divide on both sides with minus 4. Use the rule while dividing with a negative number. Inequality reverses. That is minus 4x divided by minus 4 less than or equal to minus 16 by minus 4. You will be getting x less than or equal to 4. X less than or equal to 4. Now solve. We need to solve, which means we need to find the solution set. What is the solution set here? Solution set for the first case. It is a set of real numbers. Replacement set is a set of real numbers. So first we have to add that condition and the condition that we got. That is x such that x belongs to real numbers and x less than or equal to 4. This is our solution set. Just give the conditions. Two conditions. One is that we get from the replacement set. X should belong to real numbers. And the second that we have determined. That is x less than or equal to 4. Okay. Let's move on to the second part. Second part, the question is 8 minus 3x less than or equal to 20. 8 minus 3x less than or equal to 20. Minus 3x less than or equal to 20 minus 8. 8, when it comes to the RHS, it becomes minus 8. Minus 3x less than or equal to, what is 20 minus 8? 12. Then, to get x, we have to divide on both sides with the negative 3. While dividing with negative 3, the sign of the inequation reverses. Less than or equal to becomes greater than or equal to. So, x greater than or equal to 12 divided by minus 3. Minus 4. Yes? We will be getting minus 4. So, this is our condition. X greater than or equal to minus 4. Let's write the solution set. Oh, you got the answer? Okay, let's write solution set. What are the conditions? X should be a real number and a number that is greater than or equal to minus 4. X such that x belongs to real numbers and x greater than or equal to minus 4. This is our solution set. Okay. Let's move on to the third part. Third question. 5 plus x by 4 greater than x by 5 plus 9. Taking x terms together, x by 4 minus x by 5 is greater than 9 minus 5. 9 minus 5. Taking LCM, 4 and 5. The LCM is 4 into 5. 20. Then, here 4 into 5 is 20, which means we'll be having 5x minus 5 into 4 is 20. We'll have 4x greater than 9 minus 5. What is 9 minus 5? 4. 4. 5x minus 4x is x by 20 greater than 4. Now, multiplying on both sides with 20. 20 into x by 20 greater than 4 into 20. 20 is a positive number, therefore inequality remains the same. There is no reversing of inequality. Cancelling 20, we get x greater than 20 into 4, 80. X greater than 80. Now this is a condition. Okay. Replacement set is set of real numbers. Then we can write solution set as x such that x greater than 80 and x belongs to real numbers. This is our solution set. Now the fourth part. X plus 3 divided by 8 less than x minus 3 by 5. We'll be taking this 5 to the opposite side numerator and 8 to the opposite side numerator. Clear? That is 5 into x plus 3 less than x minus 3 into 8. Okay. Removing brackets. 5x plus 5 into 3, 15 less than 8x minus 24. Now, we have a equation where you can take all the x containing terms to one side and constants to the other side. That is 5x minus 8x less than minus 24 plus 15 becomes minus 15. Minus 15. 5x minus 8x is minus 3x. Minus 3x less than minus 24 minus 15. Minus 39. Minus 39. Now we have to divide with minus 3. Dividing with minus 3, remember, we have to change the inequality. Less than becomes greater than. Reversing inequality, minus 3x by minus 3 greater than minus 39 by minus 3. You will be getting x greater than minus 39 by minus 3. That is plus 13. So, x is a real number that is greater than 13. Okay. This is a condition for x, and in the replacement set it is given that x should be a real number. We can write solution set is equal to x such that x greater than 13 and x belongs to real numbers. X greater than 13 and x belongs to real numbers. Clear? Here is our fifth problem. Question number 8 of exercise 4A. Find the smallest value of x for which 5 minus 2x less than 5 1 by 2 minus 5 by 3x, where x is an integer. Now here we have a mixed fraction. This mixed fraction, we cannot keep it as it is and solve. We need to convert it into improper fraction first. We know to convert, right? We have studied about fractions. So, question is 5 minus 2x less than 5 1 by 2 minus 5 by 3x. Let's change this 5 1 by 2 to a improper fraction. How do you change to an improper fraction? We have to multiply these numbers and add the numerator. 5 into 2 plus this numerator term, that is 1, divided by the denominator part. Here the denominator is 2, that is the same. Okay, 5 into 2, 10 plus 1 divided by 2. We will be getting 11 by 2. 5 1 by 2 is equal to 11 by 2. Now you can substitute in this inequation. 5 minus 2x less than 11 by 2 minus 5 by 3x. Taking x terms together, minus 2x, this is our x term on the RHS, minus 5 by 3x becomes plus 5 by 3x, less than 11 by 2 plus 5, taking it to the opposite side, becomes minus 5. Next part, taking LCM. Here the denominator is 1. Here also the denominator is 1. LCM will be 3. Okay. In the numerator, we'll have 3 into 2x. What is 3 into 2x? 6x minus 6x plus 5 into 1. 5 into 1 is 5. That is 5x. Less than, here again the LCM is 2. 1 into 11 minus 5 into 2. 5 into 2, 10. Minus 6x plus 5x is minus x divided by 3 less than 11 minus 10, 1 by 2. Next step, we can multiply with minus 3 on both sides. Multiplying with minus 3. Why am I multiplying with minus 3? I need to remove this negative sign and the 3 from here. Yes? When you multiply with a negative number, the sign, the inequality reverses. So this becomes minus 3 into minus x divided by 3 minus 3 into 1 by 2. Minus 3 into 1 by 2. Okay. Negative 3 and 3 can be cancelled. This negative and negative, negative into negative, it becomes positive x. X greater than minus 3 by 2. Minus 3 by 2. Okay. What is minus 3 by 2? Converting it into decimal, you will be getting x greater than minus 1.5. 3 by 2 is 1.5. So this is our condition for x. X should be greater than minus 1.5. Next, x is an integer. We need to find the smallest value of x. X is a number that should be greater than minus 1.5. Minus 1.5 lies between minus 1 and minus 2. Yes? Minus 1 and minus 2. Which is greater? Minus 1 is greater. These are negative numbers. Minus 1 is greater and minus 2 is smaller than minus 1.5. Now x is greater than minus 1.5. That is, the value of x can be minus 1. X should be an integer. Minus 1 is an integer, but 1.5, minus 1.5 is not an integer. X should be a number that is greater than minus 1.5 and an integer. So, the final answer is x is equal to minus 1, which is the smallest value of x such that x is greater than minus 1.5 and x is an integer. Clear? Problem 6. Question number 9 of exercise 4A. Find the largest value of x for which 2 into x minus 1 less than 9 minus x and x belongs to w. What is w? W is the set of whole numbers. Okay. Here we have to find the largest value. In the previous question, we determined the smallest value of x and x was an integer. Here x is a whole number. We need to find the largest value of x. Okay. Let's solve. We have the inequation 2 into x minus 1 less than or equal to 9 minus x. Removing the brackets, we get 2x minus 2 less than or equal to 9 minus x. Taking x to the left hand side, minus x becomes plus x. 2x plus x less than or equal to 9 minus 2, taking to the RHS becomes plus 2. 2x plus x, 3x. 3x less than or equal to 9 plus 2, 11. What is x? X less than or equal to 11 divided by 3. X less than or equal to, converting this fraction to decimal, we'll be getting 3.666. Can write it as some 3.67. Okay, this is our condition for x. X should be less than or equal to 3.67. Equal to is not possible because x is a whole number. X should be the largest value. Okay. We need to find the largest value of x. Which is the largest value? A number that is less than 3.67 and a whole number. 3. Correct. 3. That is x is equal to 3. This is the largest number. Next whole number is 4. But 4 cannot be included here because x is less than 3.67. 4 is a number that is greater than this, which is not possible. So, the largest value of x is equal to 3, which is a whole number. Clear? Let's move on to the next question. Okay, here is our last problem for today. Problem 7. Question number 12 of exercise 4A. Given x belongs to whole numbers, find the solution set of minus 1 less than or equal to 3 plus 4x less than 23. Here we have two inequalities. Less than or equal to less than. We have done a similar question before. You remember? We have taken two different parts and solved separately and reached at the condition for x. Same thing. Here the first part is this one. That is minus 1 less than or equal to 3 plus 4x. From this, we will reach to a condition for x. Here, taking constants to one side, minus 1, minus 3, plus 3 becomes minus 3, less than or equal to 4x. That is, minus 4 less than or equal to 4x, dividing with 4, dividing by 4 on both sides. 4 is a positive number, right? Dividing or multiplying with the positive number, there is no change in the inequality. There is no reversing of inequality. Okay. minus 4 divided by 4 less than or equal to 4x divided by 4. Minus 4 by 4 is minus 1. Minus 1 less than or equal to 4 by 4. 1. That is x. Minus 1 less than or equal to x, which means x greater than or equal to minus 1. This is our first condition. Okay. Next part. This is the second part. 3 plus 4x less than 23. Now, taking this 3 to the RHS. 4x less than 23 minus 3. 4x less than 23 minus 3, 20. Dividing on both sides with 4. Dividing by 4, you get 4x by 4 less than 20 by 4. 4x by 4 less than 20 by 4. 4 and 4 cancels. You have x here. X less than 20 by 4 is 5. Okay. Now we have got the conditions for x. This is our second condition. So x is a number that is less than 5. Also, x is greater than or equal to minus 1. Okay. The solution set is a set of whole numbers. Negative numbers are not included in whole numbers. Here, x belongs to whole numbers. What is the solution set then? Solution set. We can write x as x is less than 5, also greater than or equal to minus 1. This is our final condition for x. Minus 1 less than or equal to x less than 5. Now when we take the condition, x is a number that belongs to the set of whole numbers. We cannot include negative numbers. Okay. So x is equal to minus 1. Not possible. Next number is 0. Can we include 0? Yes, 0 is a whole number. So the solution set includes 0. Then next whole number 1, 2, 3. X should be less than 5. Cannot include 5. Up to 4. So this is our solution set. Very easy question, right? Yes. That's all for today. Today we discussed what linear inequations are. We studied the different rules that are used to solve linear inequations algebraically. Hope you all enjoyed this session. I'll be back in the next video. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.